Okay, today we're going to talk about the small lathe nomenclature, all of the names for all of the different parts. It's important that you know the name. It's important that as a class that we call everything by the same name. So we're not going to wind up with one student calling it one thing and another student calling it something else. We all need to use the same name for the same part. Most lathes have exactly the same parts. They're a little bit different in size and sometimes configuration. But everything that we will talk about on this small lathe is exactly the same as it would be on the larger lathes. You'd have exactly the same parts and they're all called exactly the same thing. To start with, the key to the whole thing is the bed. The bed of the lathe is what carries all of the tools, and it maintains the concentricity when you start turning, so everything is on the same center. It's a very heavy bed. It's all cast iron. Most lathes do have cast iron beds. You have two major sections above the bed. You have the headstock and you have the tailstock. We'll talk about the headstock first. It has a hand wheel on the outside, and that turns the spindle. The spindle is where you attach all of the parts that you want driven. It's driven by a belt. Now the belt has three positions. For our purposes here, it will always stay on the center position. Students will never ever change the belt position. The motor that drives it is mounted on the underneath side. It's completely out of the way. This lever is the motor locking lever. If you loosen that, then you can move the motor up and down, which changes the tension on the belt, allowing you to change that. That's something that you don't need to know because you're never going to change this belt. Now, this part is called the tool rest base. Its common name is banjo, and it supports the tool rest. Now these are interchangeable. You can put a number of different tool rests in here depending on what you're trying to turn. Normally you'll use a straight tool rest. You can control the height with this locking lever, which would be the tool rest locking lever. You can lock the tool rest base in whatever position you want with the tool rest locking lever. The thing you need to know about all of these locking levers is it does not require a great deal of pressure. You don't want to crank on this thing. All you need is enough pressure to make it snug, and it will not move. The same for the tool rest. You don't need to put a great deal of pressure. It's not going to move that easily. Now, at the other end of the lathe is the tailstock. Now the tailstock has a number of parts to it that you need to be aware of. It has the locking lever that will lock it into position. The part that actually extends out is called the quill, and it has its own locking lever. So this would be the quill locking lever. And this is the quill hand wheel that moves it in and out. Now, when it comes to powering up the lathe, the first thing that you need is the key. Now, this is just a plastic key that fits right in here. You cannot turn the lathe on without this key. It has a speed control knob here. This allows you to control the RPMs on the spindle. It also has a forward and reverse switch. So you can change the direction of rotation on the spindle. Now, once you have the key in place and you're ready to do something, you can plug it in. The spindle will turn, and the readout gives you the RPMs. Currently it's setting at about 1420. The normal speed for turning is going to be about 1200. It doesn't have to be exactly 1200. You'll never get it exactly 1200. But you just need to be in the range of 1200. There's a few things that will come with it. This is a drive center. It has prongs and a center pin. This is what you actually drive into a piece of wood to attach it so it can spin. It has a number 2 Morse taper on this end. The inside of the spindle is also a number 2 Morse taper, and that will go right in there. For the entire length of that taper, you have contact surface. So once you put it in gently, you cannot take it out. The only way that you can get this out is with a knockout bar. The knockout bar is inserted through the hole in the end of the hand wheel, and you bump it to get it out. Once it's firmly inserted, you just bump it and it will come out. The other end normally has a live center. This is a bearing system with a pin. So this turns at the same speed that the spindle is turning. It also has the number 2 Morse taper, and it will go in this end. And then when you have both of them in place, you can put a piece of wood between them. When you do that, it's called turning between centers. To get the live center out of the tailstock is done differently. Remember, you use the knockout bar on the headstock. The tailstock is self-ejecting, which means that when you retract the quill into the tailstock, it will reach a point where it will stop turning, and that breaks the friction fit between the 2 parts, and it comes out. It's called a self-ejecting tailstock. Okay, now, in addition to turning between centers, there's several other different ways that you can turn on a lathe. One is a faceplate. Now, this is just what you would think it is. It's a faceplate with screws and a threaded portion that actually goes on to the spindle. And you would use the holes with screws to attach to the piece of wood, and then you would turn it from there. There's a lot of times when the faceplate is the best option for turning. Another option for turning in a cantilevered situation where you're only actually attached at one end is a chuck. Now, all of our chucks come in boxes, and you'll notice how it's laid out in here. This part goes on top. The chuck is open to allow the key to sit in between the jaws. That's the way it has to go back in the box. So you would take the key out, take this bar, put it through the hole in the key, and put the keeper back on it. And now you have your chuck key. The chuck has concentric jaws, And it also has the threaded portion that will screw onto the spindle. And then your key will open and close the chuck jaws. A chuck can hold a piece of wood in two different fashions. You can cut a recess into the piece of wood, slip it over the outside of the jaws, and then expand the diameter to hold it from the inside. Or you can cut a tenon in the wood, which is a protrusion where it would actually go inside the chuck jaws. And it would be a tenon that would be small enough in diameter to fit inside here. And then you would tighten the jaws down onto the tenon. So you can hold a piece of wood in a chuck either by expanding the chuck jaws or compressing them. Now, when you're finished turning with the chuck, you would open the chuck jaws sufficiently to go back into the box, take off the bar, and then that goes, and then the lid will close. If you do not open up the chuck jaws, and this just sits on top, the box won't close, and we wind up destroying the box. So it's just simply required. Get used to it. It's the way it's going to have to be. You will always put the box, the chuck back in the box, just like that. And that should just about do it on that. Okay, now, as I said before, most lathes are the same. This is our largest lathe in the shop. It's a Powermatic. It will turn a full 24-inch diameter, where the smaller lathes that we looked at earlier will only turn 12 inches. But again, the parts are the same. You have a headstock and a tailstock. You have a tool rest base and you have a tool rest. You have a spindle. It's larger than the smaller lathe. So it will take different face plates and different chucks. But everything else is essentially the same. The power arrangements are a little bit different. It also requires one of the switches that you have to put in here. But essentially it's the same. It has the same parts that have the same function. The unit is just larger, and it will turn a much larger piece of wood. Okay, now we're going to talk just a little bit about lathe safety. There's an old saying in the wood turning world that you should never put a piece of wood on a lathe that you cannot afford to get hit in the face with. Because of that, you never ever operate a lathe without at least safety glasses. That's all that we require in the shop because we only turn small pieces of wood. But there are times when you would want to use a full face shield when you're turning. There are a number of students that come in with full face shields because that's what they want to wear. It's not required because, again, we don't turn very large pieces of wood in the class. So safety glasses are always required. Anytime you're mounting a piece of wood, taking a piece of wood off, changing anything on the business end of this lathe, it needs to be unplugged. You would never have this tool plugged in and start trying to change something on the spindle. So if you're going to mount wood or take wood off or change attachments on the headstock, it's all done while the machine is unplugged from the wall. Okay, let's stop.